Okay, are we live? Okay, let's see. Does it look like we're live?
Looks like it.
All right, very good. Let's go ahead and get started. All right, so welcome to the first Horner live stream. We're doing it in kind of mid to late December to keep it a little bit under the radar as we figure this out. So, why are we doing a live stream? What's the point? We do regular webinars, and we've been really happy with those results of how those have been received and the way we've been able to get information to our customers. But the webinar format is a little limiting. Typically, we present material. We may intersperse a little bit of, pre-recorded software demonstration or product demonstration, and then we answer questions at the end. And it's a wonderful format that we're going to keep. You'll see plenty of webinars next year. But with COVID-19, we have to continue to find new ways to interact with our customers because, our vendors that supply us with products, they're not allowed to come in and visit us in person. So there has to be even more ways for us to interact with you so that we can get you the information you need and so you can get us feedback. So we're going to try a live stream format.
Real quick, Chuck.
Sure.
Showing me, not you.
I'm showing you. Well, hey, there we go. Let's go back to me. That's interesting. See, let's show both of us. How about that? Let's do that. I'm going to bring in Casey Gardner here, which I guess I brought in earlier. Casey is sales application engineer at Horner, one of our valuable resources. How's it going today, Casey?
Not too bad. How you doing, Chuck?
I'm doing great, having a few technical difficulties, but that is to be expected, I suppose.
It's a learning.
There you go. It's a learning phase. So that really illustrates another reason why we want to do some of these live streams is it gives us an opportunity to show some of the other folks that are great experts here at Horner, and it's not just Chuck Ridgway in front all the time like we do for the webinars. So I like doing it. It's a great experience, but we've got a lot of great people here at Horner, and we want to give you a chance to interact with them as well. Okay. So also joining us today is Marcy Tyree, although she's joining us from behind the scenes, if you will. So there's Marcy chiming in via chat. And keep in mind that during these events, you'll always have an opportunity to chat in. We'll select what we show and what we don't show, so don't worry. Everything any question you might have or any comment you might have won't automatically necessarily be brought right in. But one of the advantages of this format is the fact that you have the opportunity, if you attend some of these live streams, maybe to steer the conversations or the questions in the directions that you want to go without necessarily having to wait until the end to ask your question. So there are benefits there. And then there's also benefits in the fact that we will post these live streams on our YouTube channel, and we'll also take snippets from them as we demonstrate certain features and functions and that sort of thing that we'll also use to create some additional video content that's shorter and more concise for a specific function, for instance. Okay, so let's just go ahead and jump right in. Okay, so what's on our docket for today, what we're planning for today is we're going to go ahead and demonstrate, actually more than just demonstrate, we're going to go ahead and preview a new product that hasn't even been on the radar yet. Okay, so we at Horner, we have a product roadmap that we've shared with our customers and our distributor partners. I've had a couple webinars discussing our software plans and our hardware plans that we have for 2020, 2021, and beyond. But sometimes we don't follow the script. Sometimes we'll have an opportunity as a small company to develop a product for a special project, and voila, the next thing you know, a few months later, we've got a completely new product that we didn't even plan on, a year ago or maybe even 6 months ago. So today what we're going to do is we're going to go ahead and preview that new product. So let's go ahead and take a look here. So, all right. So this is the new product I want to go ahead and demo for you today. What is it, you ask? Well, it is a new Horner IP67 I/O block. How about that, huh? Really nice. Now this is something that we've never talked about before with our customers. We've had a few partners that we've mentioned it to, but this is really a brand new product. It's not ready to sell yet, but it's getting pretty darn close. And again, I'm going to preview it for you here for the first time anywhere. So let's kind of walk through the product a little bit here. All right, so let's start up here. So as many of you may already know, a lot of our remote I/O products are based around C-SCAN, which is our proprietary CAN network. And this product is no different. So what we have here is we have a CAN in and a CAN out port. So that's where we make the network connections. Now, for those of you who aren't necessarily familiar with what IP67 I/O is, basically it's I/O that you can put out right into the environment of the factory. You don't have to put it inside of a panel because of the fact that it's molded and it can be directly washed down. It uses sealed connectors, and you can put it right outside or when I say outside, you can put it right out in the environment, not inside of a control panel. And our products have been used in these applications for years, but with third-party I/O. And now we've got a product ourselves, an I/O block ourselves, that can be used. That'll be very cool. All right, so let's walk through it. I started to mention the fact that we have a CAN in and a CAN out port. So you can just use standard cabling and daisy chain them in and out. Okay, very cool. Also, power comes in from here as well. So just like Smart Block or Smart Rail or our other I/O options, they get power from the CAN connector, and that's true also with this I/O block as well. All right, so here we have CAN in and CAN out. Now, if this guy is on the end of the network, then what we're going to do is you'll have a CAN in or a CAN out, but not both. And then there's a standard plug with a resistor embedded in it. That is a standard molded product that can be purchased to go ahead and give you network termination, again, with using the same connectors. So that's also very cool. Okay, now I'm going to skip these two connectors for now, and I'm going to proceed to the next 8 here. So what we have here are 4 input connectors and 4 output connectors. And we've got 2 digital inputs on each of these connectors and 2 digital outputs on each of these. Well, using a standard cable, how are you going to access, let's say, 2 sensors on a single port if you've got the 2 inputs here? Well, just like a lot of companies that sell IP67 I/O, we've got these splitters that will be used to go ahead and provide a connection for both, for 2 sensors, for instance, with a single port. So you'll be able to take advantage of all 8 digital inputs and all 8 digital outputs if you choose by using these splitters. And if you're just going to use 1 sensor per port, for instance, or on a certain port, again, that's no problem. You can just plug your standard cabling directly into the port and only use one of the two connectors. Okay, now let's go ahead and take a look down here. Let me zoom in a little bit here. All right, center this back up. At the bottom here, we've got LED indication for the 8 inputs and the 8 outputs. Now, this is all sealed, okay, so it's wash down rated, no problems there. In addition to those LEDs, we've also got network status, power, and OK lights like we have on all of our remote I/O products. So that's very cool there as well. And I'll come back to this area of the product here in a little bit. All right, now, believe it or not, and I'll go ahead and zoom back up here, but believe it or not, there's actually more here. Let's not, I haven't covered all the features and functions yet. On these 2 input ports, not only can we support standard digital inputs, but we can also support high-speed counting. Very cool, okay? So that means that if you have encoders, or if you've got some sensors that are going to be, responding in a very high-speed way, and you want to do totalizing on those sensors, photoeyes or something, you can do that. So these are compatible with encoders and high-speed counting in general. So not only do we have 8 digital in and 8 digital out, we've got high-speed counting. Pretty cool. Okay, still, we've got more here. Now, in addition to the digital inputs and digital outputs and the high-speed counter capability, we've actually added analog signals to some of the spare pins as well. So with the appropriate cabling, you've got analog inputs and analog outputs, 4 to 20 milliamps, available on the I/O block. So not only can you do digital I/O and high-speed counting, you can do analog in and analog out, 4 to 20 milliamp, which is by far the most popular analog signal type. Okay? Awesome. All right. Now, configuration. How might you do configuration with this product? Well, let's talk about that. I'm going to unveil this port next. Get my fingers in the way. And you'll see we've got a USB port there. Okay? So, sure enough, you can use that USB port to connect it to Seascape for configuration if you choose. Another option for configuration is this port down here. Okay? And that is a near field communications port, or NFC port. So in the future, you're going to be able to configure this module also from your iPhone or your Android app. Okay? Even more functions. That's going to be really nice. More and more products these days are showing up with NFC type interfaces, and this one is no different than that. Okay, now getting back to this USB port. All right, not only is this product a IP67 I/O block with digital I/O, high-speed counting, and analog I/O, but it supports logic as well. Yep, it's a full controller. So you can actually program this guy with ladder logic in Seascape, just like any other Horner product. And now you've got not only remote I/O capability, but you've got the capability of doing actual control as well. So pretty awesome. Okay, so that's a sneak peek at our new IP67 I/O block. I hope you're as excited about it as I am. I know that one of the fun things of working at Horner is when we go off script like this. You know, we're going to do our best to plan out our developments, software and hardware, but every once in a while, as a smaller company than the big guys, the Rockwells and the Siemens, you know, we can react to an opportunity. We can develop something and just go completely off script. And I'm really, really proud of our team in engineering and marketing and sales and the software guys, really for taking this product from not even being imagined 6 months ago to being pretty darn close to release. So that's a real testament to the team we have here at Horner who can do that sort of thing. It just makes working here a lot of fun. Okay, I'm going to go ahead and bring Casey back in here. And Casey, do you see some applications for this? What do you think?
Yeah, I think so. Definitely something like food and beverage. I could think of automotive applications where oil baths are involved, where you could see something like that. Agricultural, chemical, oil and gas, even dusty environments. I'm sure you can attest to its use in those kind of cases. So
absolutely, I've known my share of dusty environments for sure, especially recently.
So
all right,
I think it's got a lot of uses for sure.
All right, very cool, awesome. Well, the next thing we're going to go ahead and do is I think I'm going to go ahead and, well, one question I know we do have is how can we have a product that's both an I/O block and a controller? So that's a question I want to kind of answer here. So the way we can accomplish that is by, when we're using it as an I/O block, we just have a small program running in the unit so that it acts as an I/O block. And I'm going to show you a way we might configure that. Now we'll make it pre-configured with that program that you can use or not. But that's the way we would go about that. And we're going to go ahead and demonstrate kind of some of the programming involved there while we're here. Now I do have a question from Dennis. Okay. All right. Oops. Wrong one. Let's try this again. There we go. Question from Dennis. And that is, how fast are the high-speed inputs? So I don't have the exact specification, but I believe they're at least 200 kilohertz. Okay, so at least 200 kilohertz, maybe as fast as 500 kilohertz. So pretty darn fast. So that's pretty good, pretty impressive there. Thanks for that question, Dennis. Okay. All right, now I'm going to go ahead and switch over to, if I can get this comment off here, there we go. I'm going to go ahead and switch over to the software demonstration. I'm going to go ahead and pull up Seascape here. All right. Let me show you how we might go about taking any OCS controller, okay, including this IP67 IO block, and turning it into a remote IO block. Okay, so you could do this with an XLE. Let's say you had an application where you need to add 20 or 30 IO points, and it was a different mix of IO, and maybe an XLE was a good option cost-wise, or maybe even an X2 or an X4 were a good option cost-wise to add IO to the system over CSCAN, or maybe even over Ethernet. But I'm going to show how we would do it over CSCAN here. So it's really a pretty simple process. And again, we're going to provide this sort of program for this product, already pre-baked. But I'm just going to show you how you would do that with any other Horner product. So let's go ahead and go about that now. So I've already pre-configured my hardware for my controller. Okay. Now I'm going to go ahead and go to the communications section, or the COM operations section of Seascape. And the first thing we're going to want to do anytime that we're using an OCS as an IO block is we're going to want to make sure that we have heartbeats being exchanged between this device and the main OCS. So in that scenario, we're going to be doing what we would call a put heartbeat and a get heartbeat. So let's start out with a send heartbeat. So what this is a function block that effectively is sending a heartbeat to the network on a periodic basis. And we can control how often that goes out. So I'm just going to use an always on normally open contact here. I'm going to go ahead and, okay, what network ID would I use? Well, I just want to use whatever network ID has been assigned to this, this unit. And that information is available in system register 29. So regardless of how it's set ID-wise, if I use system register 29 as the network ID for this function block, it's going to show up properly, okay? And then I'm going to set a timeout. So let's say I'm going to send a heartbeat every 100 milliseconds, and then there's a status register here that we can go ahead and assign. I'm not going to talk about that much right now. Okay, so now we're sending out a heartbeat every 100 milliseconds, and the main OCS on the other end can look for that and make sure that it's there to verify the health of that particular or this particular unit that I'm programming. Okay, now I'm going to go ahead and add in I'll go ahead and make that another always on contact here. And now I'm going to go ahead and add in the get network heartbeat, because not only does the main OCS need to know that this device here is healthy, we also need to know that that OCS is healthy so that we can react appropriately and maybe turn the outputs off, for instance. So this time under network ID, I'm not using my own network ID. I'm going to use whatever the OCS's network ID is. Okay, so I'm just going to fix it at 253. We'll assume that's what it is. It could be something different, but I'll just make it 253. And then we're also going to configure how often we're expecting a heartbeat from this device. And similarly, we're going to go ahead and address or assign a specific system register. Status register to that. All right, so now I'm exchanging heartbeats with the main OCS. The next thing I need to do is exchange data, right? I've got digital inputs, I've got analog inputs that I need to get to the main OCS, and conversely, I've got digital outputs and analog outputs that need to come from the main OCS. So the way we do that is by getting and putting network words of data. So in this case, let's start with the digital inputs that we're going to broadcast to the main OCS so he can see those, okay? All right, so I went ahead and assigned this or dropped this network put function block. Okay, again, I'm sending data to the network, so I use my own network ID here. Okay, I'm going to send global data, and let's go ahead and start with digital. All right, because I'm going to go ahead and send my digital inputs to the network, my %i's. I'll make those all sourced at %i1. And we typically send those one word at a time. So I'll make that one word here. And I do want these sent on a change of state, because every time I have a digital input change state, I want that to go immediately to the network. So I'm going to go ahead and check that checkbox. Now I also have the option of sending extra transmissions but I don't necessarily, so I can either decide to do that or not. In this case, I'm just going to assign the always off contact to that because I don't need to send any extra transmissions. I'll just do it on a change of state basis. And since I'm sending data to the network only on a change of state basis, I can go ahead and make this an always on contact as well. If it wasn't change of state in that function block, I wouldn't want to do that because I could be flooding the network. But in this case, I'm not going to be flooding the network, so I can go ahead and do an always on. All right, now similarly, let's just go ahead and copy this function block here and paste it and just tweak it a little bit so that instead of sending our digital input data, we're sending our analog input data. So I'm going to switch this to analog type. Okay, again, going out as global data. And instead of coming from digital I1, let's assign AI1, and let's go ahead and assign 4, AI1 through AI4, 4 words there. Okay, so we're done there. All right, so now we have exchanged heartbeats. We've also transmitted our digital inputs and our analog inputs. Now we would add another function block here to send high-speed counter data, but for now I'm just going to skip that. Just, we're just illustrating how we would do this. All right, now let's get data back from the main OCS, and to do that we're going to do a net get. All right, so get network words. All right, we've got that there. And now network gets, we're effectively getting getting data from the network. So we're not creating network traffic when we use this function block. Therefore, it's always okay to use an always on function block with a net get because we're not creating network traffic. We're just copying data that's already there from the network into our local memory. Okay? So this is a network get function block. It's coming from the main OCS. We said in this case that was from ID number 253. We're going to start with digital data. Now, the main OCS has up to 64 bits of this type that it can send out one word at a time, that we can effectively map into our local memory. So in this case, I'm going to go ahead and leave this offset at 0 because I'm going to go ahead and copy the first 16 bits from the OCS that it's broadcasting into my local %Q address space. So %Q1 here is coming in from node 253, and it's the first 16 bits of the digital data that's being broadcast by the main OCS. And if we have a lot more than 64 outputs that need to be assigned, that's not a problem. There's other ways we can solve that. But again, for this simple example, I'm just showing you how we would do it here. Okay. And then lastly, just like we did on the input side, let's copy this block here. All right, and paste it. All right, and then let's assign our analog outputs here. So we're going to get this from analog data. We'll leave the offset at 0. In this case, let's make it 2 words, not 3, but 2 words, because we've only got 2 analog outputs that we're actually sending out. Okay, so this, in a very simplistic way, shows you how you can very quickly and easily move I/O data and create a program, a simple program, in any OCS device that you want to use as remote I/O. Now, there's some subtleties here that we're going to want to go ahead and address. For instance, I'll want to add a little bit of logic here. On my get heartbeat, I'm going to want to add a coil here so that I always know that the OCS, the main OCS, is healthy. So I'm going to go ahead and just call this T1, and I'll give it a name of OCS OK. So what that means is if I'm successfully getting the heartbeat from the main OCS, this bit is on. So I could also set up, I also really should, add another rung here that says if the OCS is not okay, then let's go ahead and write all zeros to our analog outputs and our digital outputs so that we're in a safe state when that occurs. Okay, so that hopefully will give you a good flavor about how really you can take any OCS product and write a very simple program to turn it into a remote I/O block, and that might be a really cost-effective thing to do for your application. It really might be. Okay, so I think we're going to go ahead and wrap things up here. It's been a relatively short live stream today, but again, we're just kind of getting our feet wet. Now, as we move forward with this format, the plan is as follows. So what we will do is We'll send an announcement out approximately at least a week ahead of any live streams, letting you know what topic that we're going to cover. And so you will know, unlike this one, where we just kind of teased you with a sneak preview, we'll let you know what topic we're planning on covering in general, but we'll always have the opportunity to go off script a little bit if you have any other particular questions that you may have, even if they're not related to the subject at all. There's a good chance we can go ahead and address it. So really see it as an opportunity, again, to get in front of one of us, multiple. In this case, we have Casey involved today. We're bringing Casey in again. So we'll have an opportunity to get in front of you all and answer any questions that you might have, present you some good information, and then even if you can't attend the live streams, we'll take some of this information, boil it down, and all that sort of thing. Now, in the true spirit of this format, I did get a question from Chris, and I'll go ahead and bring him up here. When will Service Pack 4 be released? It would not be a webinar or a live event of any kind if I wasn't asked about software releases, which is perfectly fair. Great question, Chris. Okay, so frankly, Service Pack 3, that was a little bit rough from a release, frankly. So we're doing things a little differently with Service Pack 4. We've been testing, we tested Service Pack 3, don't get me wrong, but we've taken extra steps with Service Pack 4. It's in the final stages. It's already been tested by our testing team. Our applications group is getting it tomorrow, so they can work with it for a week or so. We've got a lot more internal formal training so we can support our customers better. And then when we release it, probably right at the first of the year, we probably won't release it before Christmas, but probably right at the first of the year. At that point, it will have been in front of our application group and probably almost certainly for some time in front of some beta customers. So if it gets delayed beyond the first of the year, it'll be only because we're going to give some actual customers a chance to work with the beta version of it for a week or two before we give it to everybody else. So if you're interested in being a beta customer, let us know, and we'll sign you up to participate in that. Okay, and I would expect that betas will go out. They will go out before Christmas. I'd be surprised if they don't. Okay. All right. Anything else to add, Casey?
Not in particular. I would say we'll be editing some videos and have some on the channel as well. So if you can't make the live streams every time, we'll have some edited versions where you can recap the content later on and then add comments and just like you would any other YouTube video.
Great.
We'll get back to you.
Awesome. Okay, well, I think we're going to go ahead and wrap things up for today. And again, I want to thank you all for joining us for our very first Horner live stream. It won't be the last. We'll get you announcements like we got for this one. We'll let you know what the topics are going to be in advance, and we'll give you a chance to go off script and ask us anything that you want to ask. And we might even be able to demonstrate features and things on a live basis by request. So once again, thanks for joining us.
Thanks, guys.